A warm welcome to you all, my dear students. In our previous class, you have learned how sound is produced in human, and also you saw that sound travels in solid, liquid and gaseous shape also. So how sound is produced? Yes, sound is produced through vibration. So which of the organ in the human body vibrates when we speak? Yes, the vocal cords or vocal box or larynx is the part which vibrates when we start speaking. So it is the part which vibrates when we are trying to speak. And also you saw that sound travels in solid, liquid and gaseous. So in which state the the sound travels faster? Yes, in solid the sound travels faster because of their molecular arrangement. So the molecules are closely packed. So when the body vibrates, when the particle vibrates, it passes on the vibration very easily. So sound is heard more in solids. So next concept you are having is how do we hear sound? So next concept is how do we hear sound? So this is the structure of ear. As you can see, this is the human ear, and here we have a brain. So this is the structure of ear. Now in today's class, we shall see how we can hear the sound. So this is the human ear. So imagine I have kept a speaker here. So when I turn on the speaker, the air particles which are present near the speaker vibrate. So when I turn on the speaker, the particles around the speaker start vibrating, and this vibration will pass on to our ears, and this vibrations which is created by sound will pass on to our ears. As you know, this human ear can be divided into three parts. One is outer ear, inner ear and middle ear and inner ear. So from this part, it is outer ear. Outer ear is also called as pinna, P-I-N-N-A, and the middle section is called as middle ear, and this part of the ear is called as middle ear. And this part is called as inner ear. So human ear can be divided into three parts: the outer ear or pinna, and the middle ear, and then the inner ear. So you can see when you look into your ears, or when you see the structure of ear, you can see a funnel type. You can see a hole. So this is nothing but here we are having a funnel type structure. So this is the opening of the ear where the vibrations travels through this hole. So this is the funnel like structure. You can also see here there is a hole in the outer ear. When the vibration is created, when the particles are vibrating, when the sound is produced, it moves on to the outer ear through this hole, that is a funnel. Then it moves on to this part, that is eardrum. So here we have eardrum. Eardrum is nothing but it is a membrane. It is a thin membrane which is made up of 3 layers of skin. So here you can see this is the eardrum. So when sound is produced, so here we have kept some speaker. So when sound is produced, the particle near the speaker starts vibrating. This particle starts vibrating, and this vibrations travels through our ears through the funnel. So we have a hole in our ears that is called as funnel. Through that hole, the vibrations enter to our ears and it strikes the eardrum. So here we have eardrum. So it is eardrum. The other name for eardrum is tympanic membrane. So it is also called as tympanic membrane. When the vibrations from outside enters our ear through the funnel, the when it hits the eardrum starts vibrating. So when the sound travels through our ear, inside our ears, the eardrum or a tympanic membrane starts vibrating. So it starts vibrating, and this eardrum is connected to three bones. This eardrum is connected to three bones, which are malleus, incus and stapes. So here this is one bone, this is second bone, and this is third bone. These are smallest bone in a human body. So to this eardrum is attached to three bones, that is malleus, incus and stapes. So those are malleus, incus and stapes. So when the sound vibrations enter our ears and when it strikes the eardrum starts vibrating. And then these vibrations are passed on to the bones, and these vibrations through eardrum are passed on to the bones. And here in the middle ear, some parts amplifies the sound. So it increases the sound. So when the vibrations are passed on to the eardrum starts vibrating, and the three bones which are attached to the eardrum amplifies, it passes the signals, and in the middle ear the sound is amplified, the sound is increased. And then when the sound waves or the sound signals is converted into electrical signals, when the sound enters to our ears, it is in form of sound signals. In the inner ear is converted into electrical signal, and this electrical signals are passed out through auditory nerves. So these are auditory nerves. So here in the middle ear, the sound wave is amplified, and this sound wave is converted into electrical signal, and this electrical signals are passed on through auditory nerves. So there are some nerves which are connected here. So when the signals are passed on to our ears, when it passes through the eardrum, the signal gets amplified. So it gets strengthened. So when it gets strengthened, later and the later part, it gets converted into electrical signals. Sound signals is converted into electrical signals, and this electrical signals are passed out through auditory nerve, and this auditory nerve is connected to our brain, and this auditory nerve is connected to our brain, and our brain interprets the sound, and this brain decodes the sound which we have heard, and we can make out different types of sound. So here the electrical signals are passed on through auditory nerves, and this auditory nerves are connected to brain, and this brain decodes the signal which they have obtained, and we can hear the sound, and we can differentiate, and we can recognize different types of sound through this auditory nerves when it is connected to the brain. So the brain decodes. And there is one more thing. If this is the left ear, so the left ear auditory nerves are connected to right side of the brain. So if this is the right ear, the auditory nerve which is coming out from the left ear is connected to the right part of the brain. So the sound which we hear through the left side of our ear is decoded in the right side of our brain. The sound which we hear through right side of the ear is decoded through left side of our brain. So here this is the structure of ear. So when the sound is produced, the particles around the sound producer, or here the speaker is the one who is producing some sound. So when the sound is produced, the particles around that starts vibrate, and this vibration are passed on through a funnel, and this vibration will move and strikes the eardrum. When this vibration strikes the eardrum starts vibrating, and this eardrum is attached to three bones, that is malleus, incus and stapes. These are the smallest bones in our human body. And this in the middle ear, the sound is amplified. The sound signals are strengthened in the middle ear. And then at the later part, this sound signals are converted into electrical signals. The sound signals are converted into electrical signals. And these electrical signals are passed out through auditory nerves. So these electrical signals which are converted from sound signals to electrical signals are passed on through auditory nerve which are connected to our brain. And the sound which we hear from our left ear is located in our right part of our brain. So when we hear the sound through right side of our ear, the information which we hear is decoded with the left side of our brain. So this is how we humanly hear sound. This is how we human hears sound. So now we shall see the eardrum, how the actual eardrum looks like.
Now we shall see the eardrum present in human beings. So this is the eardrum. So you can see the thin membrane, tympanic membrane or eardrum.
So you saw how delicate is the eardrum. So eardrum is made up of 3 thin layers of skin. So eardrum is made up of 3 thin layers of skin. You saw that how thin the membrane was. The tympanic nerve or the eardrum was very thin. So only we should not pierce the sharp object into our ears. So if we pierce by if we pierce a sharp object into our ears, it may go and prick our eardrum and it can cause some damage to our eardrum. So we should not use sharp object inside our ears, and also we should not use cotton buds to clean our ears. So if you want to clean your ears, you can go to ENT specialist and get it cleaned. So we'll see a video on that.
See how thin the membrane is. So don't use sharp objects to clean your ears. Accidentally, if you poke the eardrum, it creates a hole. As you can see here, there is a hole created in this eardrum. So it is a very delicate membrane which is made up of 3 thin layers of skin. So be careful while cleaning the ears and don't insert sharp objects.
So only you should not use sharp objects inside our ears. You should not insert sharp objects into our ears. Clear? Yes. So next we shall see some characteristics of sound. Characteristics of sound. So first we shall see some characteristics of sound. So how sound is produced? Yes, sound is produced through vibration. So sound is produced through vibration. So what are vibrations? Yes, the to and fro motion is nothing but the vibration. So to and fro motion is nothing but the vibration. And this vibratory motion is also called as oscillatory motion. So what are vibrations? So it is nothing but the to and fro motion. So it is a to and fro motion. The other name for vibratory motion is oscillatory motion. This vibratory motion is also called as oscillatory motion. Vibratory motion is also called as oscillatory motion. So in other words, vibration can be called as oscillation. Oscillation is nothing but vibration, and vibration is nothing but oscillation. So now, so this is a rigid surface. To this rigid surface, we shall connect a string. So we are attaching a string to this rigid support. And to this string, we are connecting a metallic ball. So here we are connecting a metallic ball to the freely suspended string. To the rigid support, we have connected a string, and to the end of the string, we have connected a metallic ball. So now this is in the form of pendulum. So have you seen pendulum? Yes, you can see the image there. So this is in the form of pendulum. So now what I will do, I will take this metallic ball. So now what I will do, I will take this metallic ball and I will move it to some extreme end. So now I am taking this metallic ball. Now I am moving this metallic ball to some extreme end. So we shall mark the point. So here first the metallic bob was at one position, that is called as mean position. This is called as mean position. When I applied some energy and I raised this bob to some height, and this position is called as extreme position. Extreme position. So now the bob was at mean position. When I took the bob and raised to some height, so this position is called as extreme position. So now if I leave this bob here, what will you expect? So what happens? Yes, the bob will come back to this. We shall name it as A, and we shall name this mean position as O. So first it was at initial position, that is mean position. So when I raise this bob to some height at point A, so now when I freely release this bob, it comes back to the mean position. So first it was at point O. When I raised it to some height, it moved from point O to A. So when I release, it moves from point A to point O, and then point O to some point B. So it will come to some point, that is B. So this is also called as extreme position. So it is also called as extreme position. So first it was at mean position. When I raised to some height, it moved, let's change this position from point 0 to A. Then when I released, it came from point A to O, then O to B. So from point O to B, we shall name this position as B. So then what happens? Yes, again from B to O. So it will come back again from B to the mean position. So this completes one oscillation. So first it was at mean position. So now we are raising it from point O to A. After reaching A, it will come back to mean position, that is O, and then it will go to some extreme position, that is B, and then B back to O. So this completes one oscillation from O to A to O, O to B, and back to A. So back to A. So this completes one oscillation. So this completes one oscillation. Have you heard of term frequency? We shall see what are frequencies. Frequency is nothing but the number of oscillations per second. Frequency is nothing but number of oscillations per second. Frequency is number of oscillations per second. So this one oscillation can also be represented in form of wave. So this oscillations can also be represented in form of wave. So I told you sound travels in form of a wave. So if I consider this line as a mean position O, we should consider this horizontal line as a mean position O. So first from O to A. So I just draw a wave like this. So from O to A. So first the box moves from position O to A, then O to O, A to O. So this is A to O. Then O to B and B to O. So O to B and B back to O. So this is A, this is B. This oscillation can be represented through a wave. So if this horizontal line is a mean position. So first it will be mean position. frequency, that is number of oscillations per second. So divided by seconds. So frequency is denoted with a small letter f. So frequency is denoted with a small letter f. So don't use capital letter F because capital letter F is used to denote force. So frequency is denoted with a small letter f. So frequency is given by number of oscillations per second. So number of oscillations per second gives us frequency. Do you know what is the SI unit of frequency? The SI unit of frequency is hertz. The SI unit of frequency is hertz. And usually hertz is denoted with a capital letter H and small letter Z. So frequency is nothing but number of oscillations per second. The equation for frequency is small f is equals to number of oscillations per second, and the SI unit of frequency is hertz, that is denoted with a capital letter H and small letter Z. Or else you can represent like this also. So this is SI unit of frequency. Now question C, what is amplitude? So now we shall see amplitude. So amplitude is nothing but the maximum distance between the mean position. So here the bob was at mean position, that is initial position, that is 0. It is nothing but the maximum distance between the mean position and extreme position. If we consider this as extreme position B, so first it was at mean position O. The maximum distance between the mean position and extreme position is called as amplitude. The distance, the maximum distance between the mean position. So it was initial position when we attached the bob to the string. So this is the mean position O. The maximum distance between the position O and the extreme position is nothing but the amplitude. So this is also amplitude. So this can also be considered as amplitude. Even if you consider O and A, this can also be called as amplitude. So here also the distance, the maximum distance between the mean position and extreme position. So the maximum distance between the mean position and extreme position is nothing but amplitude. So here this is amplitude. So amplitude is nothing but the maximum distance from mean position to extreme position. So amplitude is nothing but the maximum distance between the mean position and extreme position. So if I represent the amplitude using waveform, so if we should consider this as one oscillation. So as I told you, this is one complete oscillation. The height of the waveform, this height of the waveform is nothing but the amplitude. So this height of this waveform is nothing but the amplitude. So here it is the amplitude. So here this is the height of the waveform. So this is the amplitude, and here this is the amplitude. So amplitude is nothing but the maximum distance between the mean position and extreme position. Mean position and extreme position. So this is about amplitude. So as the amplitude increases, the loudness also increases. As the amplitude increases, the loudness of the sound increases. As the amplitude decreases, the sound becomes feeble. So we shall see about loudness and pitch in the next class. class. We shall see that in the next class. So enough for today children. So